Welcome to the final video of our tutorial series on the pneumatic motor. After designing all the components together in the first videos, we focused on assembly in a group and the creation of motion studies and animations in the last videos. Today, we are focusing on another important step, drawing creation. In this video, you will learn how to create technical part drawings from scratch and how to generate them automatically. Additionally, we will show you how to create drawings for assemblies to document your designs more professionally. Let's get started right away. First, we'll begin with a simple part drawing of a prismatic component. To do this, we open the base plate with a double click from the File panel. Currently, we are still in construction mode. To switch to drawing mode, we click on Construction in the top left and select the Drawing command. Then, we choose the option from Design. Now, we can set some general options for our drawing. Since we want to create the first drawing ourselves, we leave the manual option activated. We choose A4 in landscape format as the paper size. We leave all other settings at their defaults and start directly on our first drawing with a click on OK. We can place the first view directly on our drawing sheet with one click. Then we decide on a top view to display as many details of the base plate as possible. We set the scale to 1:1 to show the base plate in its original size. Additionally, we select the option Hole under Center Marks. We confirm the main view with a click on OK. To better show the threaded holes, we next create a sectional view. For this, we select the command for sectional view in the Create menu and click on the main view. We move the mouse to the center of a hole so that the snap point is on the hole. Then we slowly drag the section line upwards over the outer edge of the component and confirm the starting point of the line with a click. We draw the line straight down and complete the command with a click on the green check mark. Then we place the section view to the right of the main view. Under the settings, we activate the center lines for holes and confirm. To highlight the symmetry of the component, we now add symmetry lines. In the Geometry menu, we select the Centerline command, mark the two outer vertical edges of the component, and a centerline is automatically generated in the middle of the component. We repeat this process for the horizontal plane. The symmetry lines can be extended a few millimeters beyond the edge of the component by clicking on the small arrow to clearly indicate the symmetry of the component. Pressing the Shift key extends the line identically on both sides. Now let's move on to dimensioning. We start with the Dimensioning tool under the Dimensions menu. First, we dimension the hole distances by clicking on the center points of the two holes and pulling the measurement upwards. Snap points are automatically displayed, which help us align the dimension lines correctly and evenly. We then repeat the process for the vertical distances of the holes. For the basic dimensions of the component, we select the two outer vertical edges and place the measurement above the hole dimensioning. In the same way, we also create the dimension for the horizontal edges. We add the radius of 10 mm by clicking on the rounded edge and placing the measurement. In the section view, we dimension the chamfer of the base plate by selecting the chamfer and pulling the dimension upwards. Here, the chamfer length of 1.5 mm is displayed. Now, we add the thickness of the base plate by placing the dimension above the chamfer measurement. For the chamfer dimension, we add the angle of 45 degrees by editing the dimension with a double click and adding times 45 degrees. We use the same approach to label the radius of 10 mm. This time, we add 4 times before the dimension to indicate that the radius is identical on all 4 edges of the component. This follows the current ISO GPS standards for a manufacturing compliant drawing. For the threaded holes, we use automatic labeling. To do this, we select the command for hole and thread information in the menu under Text and click on a threaded hole in the main view. An arrow with all important information for manufacturing the threaded hole is automatically added. When looking at our drawing, it is noticeable that some dimensions and texts overlap. This is not a problem. Move all the information to a suitable position and arrange your drawing so that you are satisfied. Very nice! Finally, we will add an isometric view. To do this, we select the option First View under Create, set the orientation to ISO View Northeast, and place it in a free area in the drawing. This time, we set the view style to shaded and confirm the input. If you want to make final changes to the text box, you can easily edit it with a double click. Congratulations! Your first technical drawing is finished. If you like, you can now export it as a PDF. To do this, select the option Export as PDF under Export, choose a save location, and confirm. Don't forget to save your drawing in Fusion as well, so you can access and edit it at any time through the File panel. Now, we will show you another practical way to create technical drawings much faster and more efficiently. This time, we select a rotationally symmetrical component, the crank pin. Open the component again with a double click in the File panel. As before, we switch to the drawing area by clicking on Drawing from Design. This time, we set the drawing creation to automatic. We select a 4 as the plan size and confirm the creation of the drawing. Fusion now automatically generates a drawing with suitable views and dimensions. This process may take several seconds. Once the drawing is completed, we can find it in the File panel and open it with a double click. In the right image area, you see different types of dimensions from which you can choose. Depending on what the drawing is needed for, different types of dimensions can be useful. We choose the option Symmetrical with baseline dimensions. Additionally, we set the position of the reference edge to the bottom left, as the crank pin on the left side has a more complex geometry. With the slider, you can set the number of dimensions, but in this case, we leave the setting unchanged and confirm the entry. After the drawing is created, you have the option to change, delete, or add individual dimensions. For example, we can add the missing dimensions for the chamfers, replace the dimension for the groove, and place the outer diameter on the main view. Adjust the drawing until you are satisfied with the result. Finally, you can save your drawing again. Before we start with our assembly drawing, we want to show you some more exciting options for creating individual part drawings. To do this, we open the crankshaft and create a new manual A4 drawing. We select a side view and place our view. In technical drawings, hidden edges like the drilling cannot be directly dimensioned. To circumvent this and still dimension the drilling of the crankshaft in our main view, we select the Breakout View option under Create and click on our first view. Now we can set points, creating a circle around the hole. After we confirm with the green check mark, our crankshaft is cut in this area, allowing us to measure the hole. We can adjust the cutting depth in the menu. Another practical function that can help us with measuring smaller details is the Detail view. Select the command in the Create menu, click on our view, and draw a circle around the detail you want to enlarge. Fusion creates a new enlarged view, which we can place and dimension in our drawing. Perfect! By using breakouts and detail views, you can make your drawings clearer in the future. To now draw our compressed air engine, we also open this with a double click in the File panel. This time, we use the command drawing from Animation to switch to the drawing area. Now we have the option to select a script from our last video that our drawing should be based on. We use Explosion View 2 to clearly display all components. For the sheet size, we choose A3 this time and confirm our drawing creation. We adjust the scale to 1:1 and select a shaded representation. After we have placed our view, we add a parts list to our design. To do this, select the command Parts List from the Tables menu and place your list on the drawing. You will notice that all components have automatically been assigned a part number, which we can also find in the bill of materials. If your component numbers are not optimally positioned, you can move them at any time. Additionally, you will find more information in the parts list such as quantity, component name, and material. With a double click on our bill of materials, you can add further details like the weight. Well done! Your first clear assembly drawing is completed. Save this too, so you can make changes at any time. Congratulations! You have mastered the final important part of our basic tutorial series. In this series, you have learned how to create your first constructions with simple prismatic components. Afterward, we dealt with various methods for constructing rotationally symmetrical components. Additionally, you modelled your first sheet metal part and learned about different approaches. In the last videos, we assembled all the components in a group and added standard parts like screws or retaining rings. After the pneumatic motor was fully assembled, we checked and animated it with various methods, bringing it to life. In addition, you can create impressive animations to effectively showcase your components. Finally, we have dealt with creating technical drawings to professionally document your constructions. This concludes our series on the compressed air motor, but Fusion offers many more exciting features and endless possibilities for construction. Feel free to subscribe to our channel to not miss more video tutorials. Stay tuned and enjoy further exploring Fusion.